Hello everyone, especially the youth. Again, this is your Matinik at ang Musikero channel, now signing on. Our lesson in this session is all about oblique triangles and its applications, part 1. And this is your presenter in this session, yours truly, Danilo Guzman, who is always willing to serve and deliver knowledge to all the youth out there. But before we start the session proper, please do not forget to subscribe our YouTube channel, Matinik at ang Musikero. But before we start our session, please allow me to read first our objectives. At the end of the chapter, the students would be able to illustrate the laws of sine and cosine, solve worded problems involving oblique triangles, show mastery in applying the laws of sine and cosine in solving problems. And then, let us also have our basic definition of terms. For the first one, an oblique triangle is a triangle with no right angle. An oblique triangle has either 3 acute angles or one obtuse angle and 2 acute angles. In any case, as in any triangle, the sum of 3 angles is equal to 180 degrees. Also, an obtuse angle triangle is a triangle in which one of the interior angles measures more than 90 degrees. For another basic definition of term, an acute triangle or acute angle triangle is a triangle with 3 acute angles. Take note of this. An acute angle is always having an angle between 0 and 90 degrees. Coming up next, an obtuse angle is a type of angle that is always larger than 90 degrees but less than 180 degrees. Let us now talk about the sum of angle formula. And this is the formula that we use for the sum of angles formula. Angle A plus angle B plus angle C equals 180 degrees. Let us always remember that the sum of all angles of any given triangle is always equal to 180 degrees. And when dealing with the oblique triangles, we also have the law of sine. We have to follow this law of sine, wherein the law of sine states that a sine divided by the sine of the angle opposite it is equal to any other side divided by the sine of the opposite angle. And it can only be used if, for example, under case 1, given 2 angles and a non-included side are known, meaning angle, angle, side. Angle, angle, and a side. And then for another situation, we have case 2. 2 angles and an included side are known, or ASA. ASA. ASA means angle, side, and another angle. And then we also have the case 3, another situation wherein 2 sides and an angle that is opposite any one of them is known as SSA, meaning side, side, angle. Side, another side, and then angle. Inclusively, we have the formula, law of sine. A over sine of angle A equals B over sine of angle B equals C over sine of angle C. And this is our law of sine formula. And then we also have the law of cosine formula. The law of cosine states that the square of any side of the triangle is equal to the sum of the squares of the other two sides minus twice the product of these two sides and the cosine of the angle between them. And it is only applicable if, for example, under case 4, which is actually another situation, the three sides are known, meaning SSS, side, side, side. And then for one more situation, we also have case 5. The two sides and the included angle are known, meaning SAS, side, angle, side. Let us now have the summary of law of cosine for sides formula. For our first formula, C squared is equal to A squared plus B squared minus 2AB cosine of angle C, or it can be written also as C equals to the square root of A squared plus B squared minus 2AB cosine of angle C. Another formula, we have B squared equals A squared plus C squared minus 2AC cosine of angle B, or B is equal to the square root of A squared plus C squared minus 2AC cosine of angle B. For the third one, A squared equals B squared plus C squared minus 2BC times the cosine of angle A, or it can be written also as A equals the square root of B squared plus C squared minus 2BC cosine of angle A. Let us now enumerate the law of cosine for angles formulas. For the first one, we have cosine of angle A equals B squared plus C squared minus A squared all over 2 times B times C, or it can be written also as A equals inverse cosine of B squared plus C squared minus A squared all over 2BC. For our second formula, cosine of angle B equals A squared plus C squared minus B squared all over 2AC, or it can be written also as angle B equals inverse cosine of A squared plus C squared minus B squared all over 2AC. And then for the third one, we have cosine of angle C equals A squared plus B squared minus C squared all over 2AB, or angle C equals inverse cosine of A squared plus B squared minus C squared all over 2AB. As your presenter in this session, I would like to say that God is great, God is good. Thank you for watching our video. Again, this is your Matinikatang Musikero channel, now signing up.